Hello, I'm Prabesh. I'm a contributor to Stratum V2. Today I'm gonna walk you through the journey of the Developer Wizard. Here we're gonna deploy a Stratum V2 reference implementation full stack deployment. And by full stack, I mean something like this. We're gonna be running applications that are usually deployed both on miner side as well as on pool side, right? Since this is the developer wizard, we are focusing on a sort of complete development experience. So on the pool side, we have a Bitcoin node, a job declarator server, and a pool server. As on the miner side, we also have a Bitcoin node, and this is one of the key distinguishing features of the Stratum V2 job declaration protocol, right? And this is what allows miners to be working on their own custom templates, which will hopefully improve miner profits as well as Bitcoin's overall network censorship resistance, precisely because the miner is running a Bitcoin node. And today we're focusing on Bitcoin Core. Another application is the job declarator client, as well as a translator proxy, which is responsible for taking Stratum V1 connections and turning them into Stratum V2. Here in this image, we have ASIC Stratum V1 devices. We are actually going to use CPU miners as a way to simplify our workflow. So please bear with me. This is just for illustration purposes. We're not going to be using any real ASICs today. And another detail is also that for simplification purposes, we're only going to deploy one Bitcoin Core node. And all the applications are going to be pointing to the same Bitcoin node. But please keep in mind that this is just to simplify our development workflow, while in real deployments, the miner would be running their own Bitcoin node. So yeah, let's start it. We just click developers, and then we're going to choose testnet for today. And the first thing we need to do is download and install Bitcoin Core version 30, or maybe some later version, depending on when you're watching this video. So you can go to bitcoincore.org/download. Here I am on Mac OS, ARM, and it's important for me to download the tar.gz, not the zip. The zip would give me the Bitcoin Qt graphical user interface. That's not really what I want. I want the command line executables. So we download it, and we can decompress it. And then we have, this is the file we're looking for. So we also need to edit the bitcoin.conf file. Since I am on MacBook, this is sort of like the default path for bitcoin.conf on macOS. If you're an advanced user, basically you can put this anywhere you want, as long as you're aware of it, and then you use some extra argument here later on, right when you're starting the Bitcoin node. Here we're going to stick with the default path. So we're gonna edit this file to add these contents. And here it is. Since we are on testnet 4, I'm also placing this little identifier here before the configurations. And then we can start the Bitcoin Core node. I've already done it before, and I've already done the so-called IBD, or initial block download. And I usually do pruning just to save on disk space. So I'm gonna add this on top of the commands here. It's up to you to do that as well. By doing it, yeah, you're basically not keeping the entire chain since Genesis, right? You eventually start discarding some blocks after you validate them, and that allows you to use a little bit less of your disk. So it's basically catching up with the latest chain tip, and I've already done it recently, so my Bitcoin node is basically synced with the network. So we can confirm it's node startup, and now we need to locate where node.sock is. This is important for the so-called inter-process communication, and it's how the other applications communicate with Bitcoin Core. So we need to find that path. So let's open a new terminal and run this command here, and it's finding a lot of files here due to previous executions that I had. But the one that I'm really interested in is the one on the default path for testnet 4, right? So I'm gonna copy this line and I'm gonna paste it here. So now we are doing the pool configuration. Pool signature basically is something that would be written into the Coinbase script sig if we were not doing the full stack configuration. Since the templates will be defined miner side, it doesn't really matter what we write here. We're just gonna leave it as the default here. And then we also need to set the pool payout address. This is where the funds will go, right? Whenever somebody finds a block. There's some advanced configurations here also. Fee threshold is basically how often we expect the new templates to be coming to the pool. But then again, the templates are gonna be coming from the miner side, so it doesn't really matter what we set here. And share batch size, this is how often do we want to acknowledge shares, right? How often do we want to send a Stratum V2 submit share success message? So 10 means that every successful share submissions, there's an acknowledge message that is sent. And shares per minute basically ends up calibrating the difficulty, right? If we set this to higher or lower, we end up getting channels between miner and pool that have higher or lower difficulties. So let's continue. Now let's jump into the miner configuration. do you want to construct your own block templates? Yes, we do, because again, we are doing the full stack. So we choose this option, and user identity. This is something that is going to be used when opening a channel with the pool. So you can write /hash demo video, and it's all the channels will have this user identity when they're open. Miner signature. This is what we are going to see inside the blocks, right? So for example, this Mara pool block, they wrote this crazy string here. So /hash signature on block, right? And remember, we are doing the miner side configuration on the full stack setup, and the templates are going to be coming from the miner side. So this one is the signature that really matters, and it's going to end up in the blocks. We also set a reward address here that is used for solo mining, and that's because Job Declarator client, it has a feature called the fallback, and that happens whenever so let's say the miner has proposed a template that the pool doesn't like, and the pool for some reason rejects it. And so it's on the miner's best interest to just leave this pool, right? Just go mine somewhere else, as long as the miner is committed to the templates that it's creating. So it's gonna jump to another pool, and then as a last resort, the miner will just start mining solo, right? And it's gonna stop doing pooled mining. And in that case, we didn't address, right? Where would those funds go? So we're just pasting an address here, and I'm essentially pasting the same address that I did before. Maybe I should not do that. Maybe I should take a different address just to make it very clear how these addresses mean different things, right? So for the pool, we used, let's call it address A, and that's because when we're doing pooled mining, as long as this is not a non-custodial pool, which in Stratum v2 is kind of agnostic to. So in theory, you could do a non-custodial pool or a custodial pool. Here in SRI, the implementation is very simple. So this is a custodial pool, and for the custodial pool on the previous step, we put one address. That's where all the blocks funds, the template revenue goes to, and then it's up to the pool to distribute that to the miners. But then for solo mining, this would go entirely to the miner, right, if they found a block. But again, this is fallback. This is sort of like a worst case scenario kind of thing. You also have advanced configurations. This is pretty similar to what we had on the pool side. Fee threshold. How often do you expect to be getting templates from the Bitcoin Core template provider? And what's the minimum interval that we expect between these templates? Share bet size, same thing. Shares per minute, same thing. What's the difficulty of the shares that are gonna be arriving to the Job Declarator client? So let's just continue. And now translator proxy configuration. User identity is the same thing. This is the string that's going to be attached to the channels that the translator proxy is going to be opening. And we also have some advanced configuration here. So minimum individual miner hash rate in terahashes per second. So how much hash rate are you expecting to point to this? Let's just leave 1. And we can either aggregate channels or not. This basically means that if we have multiple machines connected to the translator proxy, do we want multiple channels or do we want one single channel? I mean, for my demo here, I'm only going to connect to one CPU miner, so it doesn't really matter. But if I enabled this, and I deployed multiple CPU miners, then all of them would be aggregating to one single mining channel. Shares per minute is pretty similar to what we had before. Bigger numbers end up in bigger difficulties for the jobs. And upstream authority public key, this is basically for the encryption. We're just gonna leave this as the default, is the development key that we have pre-configured by default. And now we have two options. We can choose Docker, or we can choose the binaries to be downloaded directly from the releases. We're gonna focus on Docker today. So now we have to clone the Sv2 apps repo. And we're gonna check out the latest release tag, which at the time of recording this video is 010. And now we're gonna enter the Docker workspace. So all the commands that we were, sorry, not the commands, all the values that we inserted into the wizard in the previous steps, now they are all available on a Docker env file. So we're going to download that, and we are going to move it here inside this Docker directory. And now we can launch the full stack with this command. So there you go. We have everything running. We have a pool running. We have a job declarator server running. We have a job declarator client running. We have a translator proxy running. And other logs are kind of mixed up in this log feed. And now we're ready to start the CPU miner. So for a CPU miner, we recommend this implementation. It lives on the Stratum mining GitHub org. It's actually a fork from this Pooler CPU miner implementation. It is mostly a C code base, C and assembly code base that we don't really maintain it. We don't really touch that code base, but we keep this fork to distribute some pre-built binaries that you can easily download and run. If you're on Mac, you might need to set permissions on that, but hopefully you shouldn't face any bigger challenges. I already have it here on my machine, so I am going to start it with this command here. So minor D, the algorithm is SHA-256D, and this is the URL, right? I'm running, I'm gonna point it to the translator proxy that's running on my local host. Actually, the port is being exposed by Docker. And yeah, I'm gonna use 2 threads, 2 CPU cores, just to avoid heating up my macOS. But there we go. It just got a mining.notify message, and it is starting to hash. It's gonna take a while before we find a share because we actually configured our deployment for 1 terahash per second, and I cannot really do that with the CPU. But hopefully this video helped show how to follow this deployment wizard, and then you can tweak these values and see what happens, and perhaps even try the non-custom template setup just to see the differences. And yeah, I hope this is useful. Bye.